A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear students, today we are going to solve the MCQs of first year physics in textbook board. So open your book on page number 27, unit 1, physics and measurements. The first MCQs that one is given, that one is the respective number of significant figures for the number 23.023, 0.0003 and 2.1 into 10 raised to minus 3. The four options are given. If you look at this one, 5, 1 and 2, 5, 1 and 5, 5, 5 and 2, 4, 4 and 2. Look at this one. Now this first number, if you go through this first number, this one is given, this number is 23.05. In this number we are having the 5 digits, so 2, 3, 0, 2 and 3. So non-zero digits are always significant. That means the 2, 3, 2, 3. These 4 are the significant, and the 0 located between these two non-zero digits is also significant. That means in a first number we have 5 significant figures. So that means in first number we have the 5 significant figures, and then in the second one, and in this number, if you go through this number, so here digits are given 1, 2, 3, 4 and 5, but in 5 digits we have the 4 zeros are before the non-zero, and decimal points is located. So the 0 before or after the decimal points are non-significant. That means that only the one significant figure. So if you go through this one has only the one significant figure, and then 2.1 into 10 power minus 3. If you go through this number, let's suppose this number, you have this one is a significant figure. We have to calculate the significant figure in this scientific notations. So the 10 power, any exponent, those numbers are not being considered in a significant figures rules. So it has only before this multiplication sign 2 and 1. So we have the only two significant figures. So this one 1 and this one is 2. So 5, 1, 2. So when you go through the options, look at this one. We have 5, 1 and 2. Option A is the correct answer. So I hope you got this answer. Now the question number 2, which among the following is a supplementary quantity? So do you know that those quantities which are capable to measure are known as the physical quantities? And regarding measurement, physical quantities are of the three types: fundamental quantities, supplementary quantities and derived quantities. So mass in SI system is this mass is a base quantity or fundamental quantity. Time is also base or fundamental quantity. Solid angle is just basically supplementary quantity. Luminosity or luminous intensity, this quantity is known as fundamental as well. So only the one quantity, that one is supplementary quantity in given options. There are the two geometrical quantities which are considered as supplementary quantities. One is the plane angle and other one is solid angle. So go through this one. This option C is a correct answer. This one is a supplementary quantity. Dear student, now the question number 3. The unit of the solid angle is, four options are given: second, steradian, kilogram or candelabra. So second basically is the unit of time, Steradian is the unit of the solid angle, kilogram is the unit of the mass, and candela is the unit of luminous intensity. So basically, this one is a supplementary quantity solid angle, and its unit is, when you talk about the unit of supplementary quantities, one is the plane angle, its unit is a radian, and the unit of solid angle is steradian. So over here, this one is the correct answer, steradian. Dear students, now the question number 4. The quantity having the same unit in all the system of the units. The quantity having the same unit in all system of units of is, so take a mass, it has a kilogram in SI system, its unit is gram in a CGS system, its unit is pound in a FPS system. So the mass has the different units in a different system. So time is the only quantity which have the same unit second in SI system, CGA system, MK system, in all systems. The time has the same unit. So option B is the correct answer. When you talk about the length in MK system, its unit is meter. SI system, its unit meter. But in FPS system, its unit is foot. So temperature as also in SI system, its unit is a Kelvin. In CGS system, its unit is degree Celsius. You have the different units. Only the time is the quantity that has the same unit. So option B is a correct answer. In question number 5, the random errors can be eliminated by. So how we can remove the random errors? Taking the number of the observations in their meaning, measuring the quantity with more than one instrument, eliminating the cause, careful observations. So random error occurs can be removed by taking the number of the observations and their meaning. When you take the average of different readings, then you can remove this random error. So option A is a correct answer. Now question number 6. Systematic error can be, systematic error, why it occurs? Either positive or negative only, or positive only, or zero error. Systematic error is because of the fault in the manufacturing of the instrument. So it may be positive or it may be negative. It can give the more reading than the actual one, or it may give the less reading. That's why the systematic can be either positive or negative. So option A is a correct answer. In question number 7, mlt raised to minus 2, this dimensional formula is given. So you have to find the physical quantity whose this dimension formula belongs to. So the first one is strain. You know, strain is a dimensional age. Basically, this one is a ratio. When you talk about the force, then F is equal to ma. So dimension of mass is equal to capital M, and the dimension of acceleration, that one is L over T square. So that's equal to M L T raised to minus 2. So that means this one is, this formula, dimensional formula is of the force. So it's very clear that this one is answer, force. Question number 8, which of the following pair has the same dimensions? So moment of inertia and torque, surface tension and force, impulse and momentum, specific heat and latent heat. So remember one thing, those physical quantities which have the same unit may have the same dimensions. So when you talk about the momentum of inertia, its unit is kg meter square, and the unit of the torque is Newton meter. So that means they might not have the same dimension. So when you talk about the surface tension, its unit is Newton per meter, while the unit of the force is Newton. So that means they both haven't the same unit. That's why the dimension may not be the same. So impulse and momentum. Impulse, its unit is, because impulse, its formula is I is equal to, when we talk about the impulse, force into time. So its unit is Newton into second, and we know that SI unit of the momentum is also Newton second. The unit of the specific heat is joule per kg per Kelvin, while the unit of latent heat is joule per kg. So out of these four, option A is not a correct answer, option B is not a correct answer, option C is a correct answer. So when you go through the option C, this one is a correct answer. We have the same units. Now the question number 10, last MCQs of this chapter. Dimensions of kinetic energy is the same as that of. So remember one thing, I already told in this lecture that those quantities which are having the same units have the same dimensions. So kinetic energy, its unit is joule. Now the question number 10, last MCQs of this chapter. Dimensions of kinetic energy is the same as that of. So remember one thing, I already told in this lecture that those quantities which are having the same units have the same dimensions. So kinetic energy, its unit is joule. When you talk about the acceleration, its unit is meter per second square. When you talk about the velocity, its unit is meter per second. Work, its unit is joule. And force, its unit is Newton. So work has the same units as that of kinetic energy. That means the dimension of kinetic energy is the same as that of work.